Žitný Ostrov is the biggest river island in Europe, surrounded by the river Danube from the south, by Mali Dunaj its branch from the north, and in short section by the Vach River. The island is a big groundwater reservoir and one of the most fertile regions in the Slovak Republic. In the northwestern edge of Žitný Ostrov, in an onshore Danube zone with permeable gravel subsoil, construction of the Slovnaft refinery began in the 1950s. The oil refinery processes almost immediately caused pollution of the subsoils and the waters under the plant. Leakages of oil substances, not indicated or eliminated in any way at that time, gradually created one of the biggest known contaminations of groundwater by refineries and petrochemical plants. In the direction of the natural flow of groundwater, oil pollution spread also inside the area of Žitný Ostrov. In 1965, 3 kilometers east of Slovnaft, in the direction of groundwater flow, a second water source in Podunajské Biskupice was built. Its capacity was 1,200 liters per second. By pumping this great amount of water, the natural flow of groundwater polluted by oil substances in the direction of the Slovnaft refinery caused the contaminated area to grow dramatically. Between 1966 and 1971, during the active time of the second water source, water contained increasingly higher concentrations of oil substances, and even after hygienic treatments by chlorine, it produced an extensive smell. In 1971, it could no longer be used as drinking water, and 70,000 Bratislava inhabitants were distributed drinking water from water tanks for several months. It was only after this situation occurred that the authorities started to seek solutions for groundwater protection. There were 2 main issues: how to save this large potable water source, and how not to liquidate one of the biggest refineries and petrochemical plants in Europe. Out of several proposals, the winning one was a concept of hydraulic protection with the help of pumping wells based on know-how from Geotest in Brno. What is the principle of hydraulic protection? Authors of the Slovnaft groundwater hydraulic protection concept, or GWHP Slovnaft, tried to get the oil pollution back to the very same place it came from by the flow of groundwaters, and polluted the second water source in Podunajské Biskupice. The main active protection element of GWHP Slovnaft is a wide-profile pumping well. By pumping the water, it was made possible to change the direction of the groundwater flow. How does hydraulic protection work? What happens in the well's surroundings? By pumping water in wells, surrounding depressions are created on groundwater tables, similar to the form of a funnel, which causes the surrounding environment water to flow into the well. Simultaneously, the slanted groundwater table enables the oil substances to flow into the well. Accumulated oil substances are pumped away by the separate pump. Essentially, the same thing happens when the water is pumped by a system of wells, where depressions around individual wells are overlapping. With this, great extension depressions are created, disabling leakage of oil substances out of reach of the depression. Spread contamination is soaked back under the ground of the refinery. Oil substances concentrated in partial depressions are continually pumped away. The advantage of a hydraulic protection system is its flexibility. For example, its ability to adapt to newly occurring conditions. This is secured by a simple method of increasing or decreasing the number of the system pumping wells, or by changing the volume of the pumped groundwater. The GWHP Slovnaft system currently consists of a hydraulic containment, solo wells, control systems, and in the past, also a second water source. The hydraulic containment is a system of 21 wide-profile pumping wells situated in the east part of the Slovnaft complex. The inner line of the hydraulic barrier consists of 10 wells. The outer line has 11 wells. In the inner line wells, pumps for groundwater and for oil substances are installed. In the outer line wells, only pumps for groundwater are installed. By a joined operation of all wells, a hydraulic containment is created, which prevents spreading of oil substances outside the plant grounds. Solo wells are wide-profile pumping wells with different calibers, which have been constructed in the places of the greatest discovered pollution. They are located in the refinery. As of January 1, 2013, their total number was 44 wells. The primary purpose of solo wells is to pump leaked oil substances away from the closest source of the leak or in the place of their highest accumulation. Hydraulic containment wells and solo wells co-create a great wide surface hydraulic depression in the Slovnaft locality. Pumped away groundwater is taken through sewage of cooling wastewater, de-oilings to the Mali Dunaj River, and part is used in the refinery for cooling. Pumped away oil substances are then further processed. In the second water source, as part of the groundwater hydraulic protection system, Slovnaft realized remediation of contaminated groundwaters outside the reach of the hydraulic containment in Podunajske Biskupice. Between the years of 1996 and 2000, a rundown regime of the second water source was implemented. A decrease in groundwater pumping was done quarterly in a way of discontinual pumping with an aim to wash up residue pollution from the area subsoil. From 2001, wells of the second water source are shot down and locally undergo groundwater quality monitoring. GWHP control systems consist of 692 monitoring wells situated in the examined region with an area of around 80 square kilometers. The first and the second control system serve for monitoring the groundwater table and the surroundings of the hydraulic containment. The third control system, which also includes wells as an indication system for tank yards, serves for pumping away oil substances as well as for monitoring the groundwater table in the locality. Data received from wells of control systems, together with data from the hydraulic containment, solo wells, and the second water source, serve for the operational management documenting the GWHP Slovnaft functions. Part of the control and monitoring for the efficiency of hydraulic protection is the realization of a number of special laboratory tests of taken water samples and oil substances. Quality monitoring of the groundwater in Slovnaft is checked by pumping wells in 2-month intervals and at monitored wells outside the plant complex once a quarter or half a year. This concerns around 220 monitored wells. The water samples are analyzed for all indicators that would show any amount of pollution. Operation and 100% efficiency of GWHP Slovnaft is periodically checked by the competent state authority, by the Slovak Environmental Inspection Authority, Department of Inspection of Water Protection. Construction of groundwater hydraulic protection wells began in 1972. In 1973, the first oil substances were taken out from Slovnaft subsoil. Before the start of GWHP Slovnaft activity, the area polluted with oil substances flowing on the groundwater table reached 4.2 square kilometers. The area of pollution with dissolved and emulgated oil substances reached 18 square kilometers. And the extent of pollution from the eastern side of the refinery in the direction of groundwater flow was 3.5 kilometers. Results of geological research and remediation activities during the past decades of GWHP Slovnaft operating clearly confirms the long-term reliability and remedial function of the system. The area of pollution free of oil substances located in Slovnaft according to the latest measurements done in 2012 are to the extent of 0.75 square kilometers. Area of pollution with dissolved and emulsified oil substances, currently also located only in the refinery, reached approximately 3.4 square kilometers. The GWHP system, at the end of 2012, pumped out and returned for processing more than 148,000 cubic meters of oil substances. From the hydraulic point of view, the flow of groundwater flow in the GWHP Slovnaft area is primarily influenced by the Danube River. A great test of the GWHP system came in 1992 when the power plant Gabčíkovo was put into operation by the changing water level regime in the area. The Slovnaft locality groundwater table increased by 3.5 meters, which caused flooding of the layer of oil substances. Even under such conditions, GWHP Slovnaft confirmed its flexibility. Increasing of the pumping of all wells of the hydraulic containment by about 30% kept the wide surface depression, and after stabilization of groundwater tables and flotation of oil substances, their exploitation increased again. Today, the regime for the groundwater table is stabilized with an annual amplitude of around 35 centimeters, compared to an amplitude of several meters, which occurred in the past, along with a tendency towards a long-term decrease of the water table. Today, Slovnaft uses modern production technologies with respect to environmental protection, especially those of groundwater. Slovnaft also runs investment and technically demanding programs for revitalizing and maintaining facilities that should significantly help to improve the situation of the area of groundwater protection. The company implemented a program for reconstruction of storage tanks and also reconstructed pipelines running from the refinery complex to a port on the Danube River. Reconstruction is also done at GWHP system wells. According to Geotest Bratislava, a GWHP Slovnaft technology guarantor, in a 2011 qualified estimate, the underground area of the plant, the groundwater oscillation zone, contains about 26,260 cubic meters of oil substances, mainly in the form of pollution on grains of sandy gravels. Certain unspecified amounts remain submerged after the groundwater level increase related to the operation of power plant Gabčíkovo. In the interest of minimizing the ecological risk towards Žitný Ostrov and the groundwater pollution with oil substances, the GWHP Slovnaft system will remain with modifications in operation for several decades, even after the end of oil processing activity in this area. Coexistence of Žitný Ostrov and the refinery is possible only thanks to the HOPV system. Its reliable function is crucial for the protection of this ecologically sensitive area, as well as for non-problematic existence of the refinery.